All right, we're going to take a look at deriving sine and cosine. So if you look on your formula sheet, we have the derivative of sine x is cos x, and the derivative of cos x is negative sine x. So these two they have on the formula sheet. But of course, like exponentials and logarithms, there's a little trick to it. There is also a chain rule. So if I write my function out like this, sine of x here, and I want to derive that, we have, according to this formula booklet, the derivative of this is cosine x, but we have to consider that inside here, this is a block, and we're going to chain rule it again. So if I chain rule the derivative of what's in the box to this cos x, the derivative of x is 1, and you notice there's no difference, but there's a chain rule, and this is going to help when we start looking at newer examples. So once again, as in earlier videos, I wrote that if you have sine of some sort of function in here, like that, if we want to derive that, pardon me, that's just a normal function, f of x. If we want to derive that, we have to take the cosine of this g of x, whatever is inside here, some function of x, and then we need to chain that onto the derivative of what's inside this block, so g prime of x. That's how we're going to do these. And the same case is if I have a function of, say I have a function cos here, and then in my block I call this g of x as well. If I derive a cos x, we get negative sine x, but there's also a chain rule, so let's look at that here. The derivative of cos x is, like written above, negative sine, but of course whatever's inside our block here, remember, so I'll even name these blocks, so I'm going to call this here a block here and a block here. We don't touch the block, it always gets rewritten inside our derivative. So the derivative of cos x is negative sine x. And then we got to chain that onto the derivative of what was inside our original cos x here. So once again, chain rule exists for both these two functions here. So let's put this in action. Take a few examples. I'll move this down here. So I'll highlight our blocks in this case. So here's my block. Blocks here, these are simple because there's nothing except for the x. Here's a block and here's a block. So let's take a look. So if I want to derive sine x, I get cosine x. So my derivative is going to be sine of the block gives me cosine of the block, but I have to chain rule that in, as you saw here. So the derivative of 2x is 2. And of course you can put that out front here to clean it up later on, but that's what we have to do. Change sine 2x to cos 2x, and then derive what's in this block afterwards and chain it on to the end. This example is a little bit more simple. All we need to do is ask ourselves, what's the derivative of sine x? Well, that's cos x. And what's the derivative of cos x? Well, that's negative sine x. So this one is not so exciting. We're done there. All right. Now, if I move this over here a little bit, let's take a look. If I'm going to derive this according to our theory here, the derivative of cos of a block is negative sine of a block. So I'm going to have negative sine of 3x. But of course, we have to chain rule that in here, right? And derive what's in the box. So the derivative of 3x here is 3. And then we're going to subtract that. I'm going to do that down here because I'm running out of room. So the derivative of sine x is just cos x. So I have that here as well. And once again, if you want, you can take this 3, put it in front here, so it's negative 3 sine 3x. Remember, this is in the argument. Don't get them mixed up. Keep them on the outside. This is the only thing we're going to keep in the argument, okay? So those are 3 simple examples. Now, the classic IB example is something like this. And if you're wondering about this notation, when you see the exponent between the cos and the argument of the cos, that can be written like this. And this here is a chain rule, but a different sort of chain rule. This is kind of like when we have x cubed and we want to derive x cubed. Normally you bring the 3 out in front and subtract this. So if you looked at the chain rule for functions that are in brackets to the power of n, normally what we're going to do is we're going to bring the 3 out in front, and this here, I call this my block in this case, and that doesn't change. So I bring the 3 out in front, cos x stays the same, I subtract 1 off there to get 2, and now we have to make sure whenever we have this format, we take this and chain that on the derivative of what's in our side of our block. So if we do that, the derivative of cos x is just, as we saw on top here, negative sine x. All right. And there we go. So bring the 3 out in front, subtract 1, and chain on the derivative of what's in the block down there afterwards. All right, so we have to be careful with that one there. Now the last one here is some unit circle fun. So we have to know our unit circle. And it's similar to this one where we have cos cubed x. Now we have sine cubed x. So the first thing I do is rewrite it so it's a little bit easier to understand when we're doing the derivative. So I do that to the power of 3. And in this case, they want the gradient of the tangent at this point x. So not only are we going to find the derivative, but we are going to insert the point x afterwards. All right, so let's start with the derivative. It says bring the 3 out in front. So that's my derivative, 3. I have sine x. This is squared. Now we're going to chain the derivative of this on to the end. So we always have to chain when we have this these brackets and some function to the power of n. So the derivative of sine x in this case, if we look again up top, is cos x. So I'm going to sit here and throw that in there, and now I have my derivative. But they would like us to find it at 2 pi over 3. So then we take out our unit circle here, and we figure out what are the coordinates at 2 pi over 3. So we have to know our unit circle. So if we have pi over 3, which is there, 2 pi over 3 is over here. And off the top of my head, I know that the x coordinate is 1/2, which is cos of an angle, and my y coordinate is square root 3 over 2. So that means on this side, I have negative 1/2 and square root 3 over 2. So if I insert them into my values, sine at 2 pi over 3, well, that's my square root 3 over 2. So this is going to turn into 3 times square root 3 over 2 squared. So sine x in this case is this point here. Remember, our y is sine x and our cosine is the x coordinate. So that's going to multiply by cos of 2 pi over 3, which is negative 1/2. So this could be a paper 1 question. You have to know your unit circle. So in the end, what you have is 3 times 3 over 4 times 1/2, which gives you 9 over 8. And you can use your calculator and look it up. You can go to Math on your calculator and then choose the option N derive. And if you do that, you can insert the original function at x is equal to 2 pi over 3 and see if you get the value of 9 over 8 or 1 1/8 in that case. So that's how we derive sines and cosines. Once again, remembering that these also have chain rules where we have to see what's inside the arguments of the sine and the cosine and chain it on afterwards when we derive them.